This video demonstrates how to operate the TriTom imaging software for an in vivo imaging experiment using the TriTom small animal imaging platform from Photosound Technologies. The TriTom imaging software consists of 5 main components: the user profile menu, camera viewer, photoacoustic signal viewer, scan settings menu, and active settings menu. The user profile menu enables users to select the location where data will be saved and create individual profiles with saved presets for easy, repeatable imaging sessions. The camera viewer shows the live video feed of the TriTom imaging chamber. On startup, the camera viewer is inactive because the default filter wheel position is set to closed to prevent accidental damage to the TriTom imaging module. At the bottom of the camera viewer, the current camera status is displayed, along with screen capture and region of interest selection controls. Additionally, the laser wavelength and output energy will be displayed in the bottom right panel when the laser is firing during scan acquisition. The photoacoustic signal viewer displays photoacoustic signals in real time. The yellow plotline shows an individual channel of interest selected by the user. The green plotline shows the maximum and minimum values of the user-selected ADC, while the blue plotline displays the maximum and minimum values of all channels across all ADCs. If the photoacoustic signal surpasses the ADC limit, the blue channel turns red to notify the user that the acquired signal is saturated. Finally, the Scan Settings menu contains the user notes log and various settings and controls for scan acquisition. When a settings menu is selected, the active settings menu will populate with the available settings for the laser, scan settings, camera settings, or photoacoustic signal viewer. Individual settings can also be pinned to the active settings menu by the user for quick access to the most used settings. Any notes or additional information entered in the user notes section will be saved as a text file in the same location as the scan data. To enable the camera view of the imaging chamber, open the laser settings menu and select the appropriate optical emission filter from the emission filter list. The TriTom standard emission filters include an observation filter for animal monitoring and a range of emission filters for covering most fluorescence imaging applications. Below the emission filter menu is the laser output energy control and laser scenarios available, which include an OPO output for acquiring a scan at a single laser wavelength, a linear scan, which acquires the linear set of wavelengths in a single scan, a custom scan for imaging a set of user-defined wavelengths in a single scan, a stepped linear scan, which acquires an individual scan for each wavelength in a defined linear series, and a stepped custom scan for acquiring separate scans for each of the user-defined wavelengths. Next to the laser settings is the Scan Settings menu that contains options for the direction of rotation for the scan timeout, angular velocity of the rotational motor, optical data save option, and an option for converting the saved scan data to a MATLAB file. To the right of the laser settings menu are the camera settings, which include options for the resolution, gain, an auto brightness function, and various other features for optimizing the optical data. Finally, to the right of the photoacoustic viewer plot is the photoacoustic viewer settings menu that contains the trigger input option, ADC gain, and options for the ADC number and sensor displayed on the photoacoustic viewer. Averaging can also be applied to all plot lines on the photoacoustic viewer to reduce noise and improve visualization of the acquired photoacoustic signals. It is important to note that averaging is not applied to the saved scan data and is not incorporated in the ADC signal saturation warning. After the appropriate scan settings have been applied, press the laser button in the Scan Settings menu, followed by the Scan button to initiate a scan. If necessary, the Stop button can be pressed at any time during acquisition to immediately stop the scan and save all data acquired up to the stopping point. Once the scan is complete, the laser will stop firing and the scan data will save in the user-selected location ready for processing.